Hello, my name is Timmis, and this is my automatic ring galaxy detection in STARRS project. This PowerPoint is going to be used for my presentation, so for time's sake I'm going to speed through this a little bit. On the right, I have an image of a ring galaxy, which is an extremely rare type of galaxy that doesn't really fit the ordinary morphology of galaxies you see on the left. They're extremely important for dark matter research, for galactic collision research, and for galactic formation research. Thing is, there have been so few discoveries of these ring galaxies as they are so rare that we can't really do any sort of statistical analysis on them. I'm going to try and fix this by creating the first ever automated ring galaxy detection software to discover as many as I can and publish a catalog in a scientific journal. Ring galaxies don't need to have a nucleus. They can be formed through galactic collisions, and there are also polar rings, which are galaxies with rings around them rather than a nucleus with a ring around them. As you can see in these images, the ring can actually be perpendicular or offset to the angle of the galaxy. The data comes from the STARRS initiative, which essentially takes these robotic telescopes that are constantly surveying the universe and populating a public database with images of galaxies and stars and nebulas. I have a specifically designed query to retrieve only galaxies from that database. Thing is, I noticed that there are many with very high noise in the image. So what I do to filter that is, in my own software, I ignore anything above 5 or 6 kilobytes. As you can see in the table, the higher the kilobytes, the higher the noise, and the lower the kilobytes, the lower the noise. Reason for that being that image compression algorithms look for patterns, and the higher the noise, the fewer the patterns, therefore the higher the file size. So anything lower than 5 or 6 kilobytes is going to go through the algorithm. I wrote the software using C# using this mgu-cv library, which is basically a .NET wrapper for the OpenCV library. I start off by taking the image from the database. I apply a low-pass filter on it to remove any noise. I convert it to grayscale, and then I set a binary threshold on it. The binary threshold is basically a number that says anything lighter than this is white and anything darker than this is black. So it sets it to a black and white image. It generates a population of images through dynamic thresholding because I don't want the luminosity of the galaxy to hinder any discoveries. I first start off by finding the negative space in the ring by using a custom flood fill algorithm to look for the black areas that can't escape the image through traversal, and then I find the white space around it and I compare the areas, and if the ratio is set to 10%, so if the black area is less than 10% of the positive space in the ring, then it gets ignored. The architecture is set up where I have an automation program which calls one instance of the ring detection program per image from the STARRS database. The reason for that being is that if for some reason the file was corrupt, or if the algorithm were to crash for some reason, then the automation program doesn't need to know about that. It just knows that that instance ended and it can move on to the next one. And that is super important that it be robust like this because it can take months to analyze the data set that I'm working with. So it takes the images from the database, one per instance of the ring detection software, and then it populates a folder of the ring galaxies. I had a little over 3 million images, and it took about 3 months to finish processing them. There are a little under 2,500 false positives, resulting in a 0.08% false positive rate. Now this is very good because anything higher than that can quickly become unmanageable because of such a large data set. And some of the false detections, as you can see on the right, are caused through saturation, strange artifacts from the camera, and also some of these spiral galaxies just happen to have a huge empty space in them. So the results of my project is I discovered 186 ring galaxies, some of them having centered nucleus, off-centered, galaxies with knotty structure, collisional rings, polar rings, and even rings that have arms branching off of them. Now 186 is going to be the largest catalog of these ever published. Here are some images of the centered nucleus, a few more, some of the off-centered nucleus. Here's some collisional ring galaxies, Here's some with the knotty structure, some polar rings, and some rings with arms. We wrote up a publication and submitted it to the American Astronomical Society. And what they do is they take these publications and they pick which journal would be best suited for it. We suggested that it go to the Astrophysical Journal Supplement Series, which is very prestigious and is the highest cited journal out of all of the astronomy journals. And we expect to get in because this is the largest catalog of these ever created. So we expect a lot of good feedback after it is published. Well, that's it. And if you have any questions, feel free to contact me. Thank you.